In this video, I will explain why we need numbers, what our number system is, and our rationale behind it. I'm going to call this composition of numbers. Numbers are an organized way of communicating quantity, a unitless counting system. We need numbers to represent how many of an object there are without needing to look at the objects themselves. For example, if someone wants to make cupcakes for everyone in this room, but they aren't here to see how many of us there are, how do they know how many cupcakes to make? We need to be able to communicate to them how many of us there are. So we use symbols to represent and communicate quantities. The simplest way to do this is by using dots or tick marks. This way, the person making cupcakes could know to make the same number of cupcakes as the number of dots or ticks that we wrote. Let's call this an expanded symbol system. The problem with this system is that with very large quantities, it can be hard to tell the difference between one number and a different number. You can see that if I write 7 tick marks right next to writing 8 tick marks, it's kind of hard to tell the difference between these two numbers. From a distance, you might not be sure if this one is too big or if it's really the same and I just wrote them farther apart. So you can see how instead of having the numbers directly correlated with the number of lines or dots that we write, we might want to have a more abstract way of representing numbers. Another way to do this is to use symbols to represent different quantities. That is, use a different sound, word, or picture for each quantity. So the way that I want to do this is represent 1, which would be this many in our expanded number system, with this arbitrarily decided symbol. 2, with this. 3, with this. 4, like this. 5, like this, and so on. One advantage of this system is that you could have a very different symbol for each quantity. This makes it very easy to tell different quantities apart. For example, if I wrote 7 from 4 like this and I wrote 8 like this, then you can tell very easily that there are different numbers. Additionally, with a compact number system, sometimes we need to represent that there aren't any of a number. With this number system, with the expanded one, you would do this just by not writing anything. But you can see that there would be a danger in that, which would be that if you just didn't write anything, it might seem like you didn't answer the question or like you didn't know or just forgot to write a number. With the compact symbol system, since we have an arbitrarily decided picture, if you will, to represent each number, we can represent nothing, the empty quantity, as this. So now we have this other system of symbols to represent different numbers. But there's a flaw in this one too, and that the main flaw is that there is an infinite number of numbers, but the symbols can't go on forever. That is to say that you can only think of a finite number of arbitrary pictures that look like this. But once you get to a certain point, there will be one that no one has thought of. If you need to represent that number, how will you do it, and how will other people understand what the number is that you're representing? So the flaw with this one is that since there will always be another number, there will always be this many, and then one more. How do we come up with an organized way of representing this in either system? The way that I want to do this is through grouping. That is, through thinking of numbers as groups of other numbers. It is much easier to think of a large number as a group of smaller numbers and to compare them that way. For example, one common way of representing grouping is through the tally system. The tally system dictates that for every 5th tally mark, instead of writing it next to the other ones like you were before, you put a cross. This groups, effectively, groups of 5. So you can see here that I have written 10 under this system, and I've written 9. If I did this without the tally marks, it might be very hard to tell the difference between them without individually going through and comparing each one and seeing that it had a corresponding one. However, with the grouping system of grouping by 5, you can tell very easily that this one is smaller because this one has the 5th one that crosses and this one does not. However, we still have the problem with using this kind of grouping in the expanded symbol system, that you have to write one tally or one dot if we're doing that for every single number. So if you want to write something very large, like the number of people in the world, or maybe the number of cupcakes that you want to make for a class, it's far too much to have to make a mark for every single one. So what is a good way of combining grouping, as exemplified here, and the compact number system, as exemplified here? Well, one way that we've come up with as humanity is for every group of numbers to write one of these numbers, so that instead of just counting ones like we are here, if we're using this, maybe we would count fives. So maybe we would write this 2 groups of 5, because there's 2. And then maybe we would write this 1 group of 5, and then 4 groups of 1. This is a little odd because it's how do you tell that this 2 is different from just writing 2? We don't know this just from writing it this way. So the way that we've compensated for it is by using 0, that number we came up with earlier, so that you always write however many ones there are in the rightmost place, and then you always write how many, in this case, how many 5s there are. And in this case, there are 4 ones, so you write you write the number of ones here, which is 4, and then you write the number of 5s here, right next to it. This way of thinking of grouping and using the compact symbol system to represent it is called the system of using bases. However, how do you tell what base to use? This is called base 5 because it's a number system that's based off of grouping every 5. But you can imagine that you could do this with base 4 or base 20 or base 37. But what is the most efficient base, or what do other people use? It turns out that in this case, the right question to ask is not what the best base is, but what the base that everyone else uses is.